In this video, we will look at how to create patterns of diagonal lines. For creating diagonal lines, it is easier to work with nested lists. In the previous video, we saw how we could move around a grid that used a flat list. Before we dive into diagonal lines, let's look at how to move around a grid that used a nested list. The example shows an 8x6 grid of position, structured as columns. Note the index numbers in the grid. Each column starts at 0 and ends at 5. To extract a position out of the nested list, we need two indexes. We can call these indexes I and j. Consider the position highlighted in the diagram. Index I is 3. And index j is 2. To extract the position we write, list 3 2. For navigation, we need to be able to move up, down, left and right. The calculations are very simple. We just add or subtract one from either the I or the j index. Here is the 8x6 grid of position again, but this time structured as rows. Note the index numbers in the grid. Each row starts at 0 and ends at 7. To extract a position out of the nested list, we again need two indexes. But the order is reversed. This time, index I is 2, and index j is 3. To extract the position we write, list 2 3. Like with the columns, for navigation, we add or subtract one from either the I or the j index. But note that the axes are reversed. The I direction now points to up, and the j direction points to the right. Now let's look at how to create diagonals. To generate the diagonal, we will structure our data as a nested list of rows. What we need to do is to extract out of this data structure a new nested list. But instead of rows, we want diagonals. In the diagram, the lines show the diagonals that we want. You can see that the diagonals will have different lengths. To get the diagonals, there is a three-step process that can be used. The three steps are: add padding, zip, and cull. Zipping and culling are two operations that you may not have used before. Zipping a set of lists restructures their content. It is easiest to understand by looking at the example. You can think of it as converting rows to columns, or columns to rows. Culling removes items from a list. One version of the cull operation is that it will remove any value that evaluates to false. Now let's get back to our diagonals. Here is an example dataset. We have a 5x4 grid of position. We have drawn some diagonal lines. These indicate the positions that we would like to connect. The padding step adds 0 values to the sub-lists. 0 values are added to both the start and the end. Notice that the total number of 0 values added to each sub-list remains constant. In this case, 3 0 values are added. Most important, notice that the positions that we want to connect are now vertical lines. Next we zip those lists. Now the vertical lines become horizontal lines. Finally we cull. The cull operation removes any values that evaluate to false. So the 0 values are all removed. Notice that we now have the lists that we need for creating diagonals. In the previous example, padding size was set to 1. The padding size can also be set to a higher number. This will change the angle of the diagonals. The diagram shows what happens when we set the padding size to 2. The total number of 0 values added to each sub-list will then be 6. And here you can see the result when the padding size is set to 3. The total number of 0 values added to each sub-list will then be 9.